What we do in the lab is we're really trying to build robots that are intelligent, that can interact intelligently with their environments, and not just interact with them, but also do this in a safe manner, as well as with the people that they are sharing the environments with.
Robots can pick up, say, this mug in many different ways, right? But with the semantic portion of our project, if we want to drink the coffee, we want to actually pick it up by the handle. And we are utilizing different AI techniques to be able to recognize that we want to interact with this object by grabbing the handle to actually allow the person to drink.
So like one of the examples that we have here, that one of the projects that we're running, is we have two robots that are playing tic-tac-toe with each other, right? And like the core technology that we're using for this is something that we call like hybrid or like neurosymbolic models. The core idea here is to use some of these like models that we've recently seen in the news, like something like ChatGPT, for example, where you can give it an instruction and it tries to answer your instruction in like an intelligent way, right? So this is usually based on language only, but what we do here in order to get this onto a robot and enable the robot to play tic-tac-toe is that we're also giving it a sense of vision. So we have a bunch of cameras that are like observing the environment as a whole. We have like cameras on the robot itself so that the robot can see what it is grasping and what it is interacting with. And we're using this vision and this ability to see what it does together with the understanding of language and the understanding of what tic-tac-toe is as a whole to teach the robot what to do in the environment itself.
Robots aren't just software, they're hardware as well. One of the hardware on the robot crashed mid-game. The other arm recognized that the arm was frozen over the board, and it saw that in order to be safe and not collide with the other arm, it had to wait for the other arm to reboot. So one arm is stuck over the board, it's frozen. The system is like, what's going on? It's analyzing it, it recognizes that it's in the space that the other arm needs to occupy. It waits, it safely retracts the arm, and then it continues playing. And the benefit of these language models is that they can reason, they can adapt, they're not hard-coded, so we have this safety in our actual deployment.
So using language to kind of prompt these robots and say, hey, can you play tic-tac-toe, or hey, can you pick up this cup? It's a really natural way for humans to control robots, and we've been finding ways to mesh these human prompts, natural language, with the actual behaviors of the robot, grounding the language into the motions. And that's kind of one of the new things that this work has unlocked, which we didn't really have previously.